Hi folks, we're going to take a look at number 13 on page 392. So they want us to show that if these two logarithmic equalities are true, then log base A of y is going to be equal to c to the negative 2, or 1 over c squared. All right, so a couple of ways to approach this. So one thing I notice is that I've got a bunch of logarithms with different bases, so I might use the change of base formula to help me get there. Another thing I can do is change all of these logarithmic equations into exponential ones and see if that can help me solve the problem. And I'm actually going to do it both ways because I do want to show you that you can solve these problems using different strategies. As long as your steps are correct, you have a good chance of getting to where you need to get. All right, so let me start with the change of base perspective. So I'm trying to determine log base A of y. Okay, but the information I'm given is in terms of logarithms of different bases. So let me use the change of base formula, and I'll start with this first piece of information. So I'll start by turning this expression into an expression using base b. All right, so my change of base formula says that this is equal to log base b of, well, the original input y over log base b of the original base a. All right, and right away I see something nice because log base b of a is indeed equal to c. So there you go. We've already got something nice here. But at the same time, the other piece of information involves log base y. Okay, so I'm going to take the numerator, which I wasn't able to simplify, and now turn it into log base y. Okay, so I'll do this all in one step. Remember, this here we established was just equal to c. So let's turn this into log base y. So this would be log base y of the original input y over log base y of the original base b. Okay, and all of that, remember the denominator, is just equal to c. Okay, but again, I see lots of nice things here because log base y of y is just equal to 1. Log base y of b is exactly that other piece of information that I was given. That's equal to c. And then, of course, c in the denominator. And this is exactly where we want to get to because 1 over c divided by c is just 1 over c squared, which is c to the negative 2. Okay, so by using the change of base formula, in this case here using it twice because I needed to use information with two different base logarithms, got me to where I needed to get to. All right, so let's look at the alternative here, is to take all these logarithmic equations and just turn them into exponential ones and see if that can get us to the answer. Okay, so let me start by turning them all into exponential equations. So this would become b to the c equals a. This would become base y to the exponent c equals b. And we'd have to show that a to the c to the negative 2 is equal to y. So this is what we want to show. Okay, so let's start with the left-hand side, like I did here. So a to the, and I'll write it as 1 over c squared. Probably nicer in terms of working with it. Let's take a look here. Well, I know that a is equal to b exponent c. So let me replace a by b exponent c, and then of course all to the 1 over c squared. But hey, something nice happens because this is a power of a power, and if I multiply these two exponents, I just get 1 over c. Okay, but now let's look at the other piece of information. B is equal to y exponent c. So I'm going to now replace b by y exponent c. Of course, that's all to the 1 over c. And similar to before, when I multiply these two powers, they just give me 1. So that's just equal to y, which is exactly what I needed to show. Okay, so in the end, about the same number of steps. Okay, the equation itself required less steps, but I had to first convert everything to exponential form. So in the end, about the same number of steps to solve either way. In one case, I used the change of base formula, in this case twice, because I needed to use two different logarithms. And in the other circumstance, I was able to turn everything into exponential expressions and then do a series of substitutions to get to my answer. Okay, that's it for this one.